Hi everybody, welcome to Module 3. We're going to talk about building a web app. The main objective in this course is to get a basic understanding of how one would even try to build a web app. Let's do a quick recap of what we covered in the last module. When a browser makes a request to a web server, the browser makes a request through the network onto the computer host. The web server processes the request, returns the response through the network and back to the browser. So if we have to build our own web app, we would have to proceed with the following steps. First thing we would do is get a unique domain name so that people can remember our web app so that they can reach it. The next thing we would do is get a computer with an IP to serve the web. Step 3 would be to link the domain name to the server's IP address. Once we have our server host set up and we can reach it, we would write the application code, which is the web server software that would sit on the host. The last step is to deploy the application code onto the computer, which is our server host. Let's look at the first step of buying a domain name. We typically buy domain names from domain registrars. Registrars take our domain name and ensure that no one else, including other registrars, can use that name while we have it. For example, in this particular screenshot, I've searched for the domain name mywebapp, and the registrar's console is telling me that mywebapp.com is already taken. It's offering suggestions to me saying, why don't you purchase mywebapp.in or mywebapp.co.in or the netapp.com. Some popular domain registrars today are Gandhi.net, GoDaddy, Name. So once we have a domain name, we can solve the first step of the problem. So the browser can now reach our computer if the user remembers the domain name of our web app. Step 2 is to set up the web server. We need to get a computer and an IP. Now the first option that we have is that we can buy a computer, we can connect it to the ISP, we can get a unique IP for that computer, a unique IP that won't change, which is called a static IP. I would then install the operating system and the web server software onto this computer. Now this is very, very hard to do. Imagine the amount of stuff that we would have to learn about hardware, we would have to talk to the ISPs, we would have to ensure that we have power backup to make sure that our website is live 24/7. So instead of doing all of this, we can just rent a computer from a particular vendor who might be anywhere in the world. And the vendor would give us a computer and would give us an IP attached to that computer, which would let us reach our computer. This business of renting a computer or renting computational power from a vendor is called hosting. And there are many different types of hosting available. The most common and perhaps the cheapest kind of hosting is shared hosting. In shared hosting, many different users are created on the same computer. This process is quite similar to us creating different users on the same computer on our own machines. For example, in your labs, you might have multiple users who log into the same computer to do their own different work. The vendor does the same thing. The vendor creates separate users on the same physical machine and gives users access. Users have to share CPU, RAM, and disk resources. All users in this case get the same IP. The second kind of hosting is dedicated hosting. Unlike shared hosting, where many users are created on the same physical machine, in this case, the vendor gives their client or user a single machine to use. And in this case, the user has dedicated access to the CPU, RAM, and disk resources of the particular machine. Dedicated hosting is significantly more expensive than shared hosting. If we are to go for dedicated hosting, the vendor also gives us a dedicated IP that is unique to us and that is not shared by us with any other user. The third kind of hosting, which has become increasingly popular over the last few years, is VPS hosting. Virtual private servers are virtual machines that are created on the same physical machine. It's like a combination of shared hosting and dedicated hosting, where we get the benefit of dedicated hosting, which is a dedicated IP and a guaranteed amount of resource. It is, however, like shared hosting because multiple virtual machines are created on the same physical machine. Hence, it's significantly cheaper than dedicated hosting. Cloud hosting is very similar to VPS hosting, but in this case, the vendor allows us to resize our compute resources dynamically. For example, we can change the size of our machines very quickly. We can provision new machines quickly. We can add more dedicated IPs for our machines quickly. Here's a quick exercise. Look at all of these hosting providers and figure out what kind of hosting they offer. Webfaction, GoDaddy, Google Cloud, AWS, SoftLayer, DigitalOcean. This is what a typical hosting provider's console looks like. You can see that they're offering different computational resources for a different monthly rental. So now that we've set up our machine, the next step is to link our domain name to our server. This link is done on the DNS provider's console. But this is actually an optional step, because even if you don't have a domain name and don't map the domain name to your IP, you can still use the IP to directly contact the web server. For example, in this case, instead of going to nptel.ac.in, you could also just go to the IP, and that would also serve the NPTEL website. Once you do link the domain name to an IP, DNS has to update throughout the world. And so let's try to understand what happens when you set the IP for a domain. The DNS system is actually a set of globally distributed databases that contain the domain name to IP mappings. And this is maintained by many name servers spread out over the internet. When you update the domain name to IP mapping with your registrar, a gradual wave of updates begins, and DNS updates are propagated throughout the world. DNS can sometimes take 48 hours to update worldwide, which is why very frequently when you're developing, you will notice that you're not able to access your server with the domain name for sometimes even up to 4 or 5 hours till the DNS is updated. To understand how DNS works in more detail, check this website out, howdns.works. This is a lovely resource to understand how your browser finally manages to get the IP of the web app that you're trying to reach. The last step now is to actually write our application code, which is the web server on our computer host. We would have to write or install a program in a language of our choice that can request or respond with appropriate information. This software will be the web server that will serve our web app. These are the 5 things that a web app does. It listens on the network, it accepts a request from the network, it processes the request, and then outputs a response in a format that the browser or a web client can understand. It then sends that response back over the same connection on the network. Now, if you think about it, this is quite complicated. Writing a program that knows how to listen to the network and how to respond to the network is pretty complicated. Developers often use several frameworks, libraries, and tools to help them write portions that are specific to their application and avoid writing the complex bits. For example, in our 5-step process, we only want to care about step 3 and 4 because that is what is unique to our web app. Steps 1, 2, and 5 are common for all web apps, and we should use a framework or a library to help us do it. For example, the LAMP stack is a very common stack that developers use. The LAMP stack is composed of Linux, Apache, MySQL, and PHP. Apache and Linux handle portions 1 and 2. PHP and MySQL handle portions 3 and 4. And Apache and Linux again handle the 5th portion. In this case, Linux is the operating system, Apache is the web server, PHP is the language in which we write our application code, MySQL is the database. We'll go into detail and understand what each of these things are actually doing. But for now, it is important to understand that the bit we want to deal with as web app developers is only step 3 and 4. Some other common stacks that developers use are the WAMP stack, which is Windows, Apache, MySQL, and PHP. The main stack, which is the MongoDB database, the Express framework, AngularJS, and Node. Django, Rails, Laravel, and Express are also common web frameworks that help us achieve step 3 and 4. Once we have written our application code and we've chosen our web server, we have to deploy this code onto our server host. Now, the server host is not a machine that we can access directly or physically. And so there are many ways to access a server remotely or remotely manage a server. Some of the most common ways are SSH, FTP, cPanel, and remote desktop. It's important to understand that deployment is a very tricky process, especially when you are making updates to an app that is already live. Deployment is also a process that needs to be very secure because you don't want random people or you do not want to deploy random code onto your server. It is important to remember that there are some things in our control and there are some things that are not in our control. For example, the domain name and the server-side code that we deploy on our server is in our control. But what is not in our control is the network, what requests browsers make, how they make the requests, and how they process the response. Let's do a quick exercise to see some of these concepts in action. So, I'm on my Chrome browser on the Wikipedia website. I go to google.com and I open up google.com. Right click on the page and you'll see inspect. Another window will pop up. Now go to the network tab on inspect element. You will see that a request is made to www.google.co.in, and if you look at the response, you'll see that some data has been sent back to the browser. This data is in fact the HTML, and this HTML is understood by the browser and rendered. If you head over to the Elements tab, you will notice that this is the parsed HTML, that the browser has parsed the response and understood the HTML and displayed that HTML as a web page. If you hover on HTML elements, you'll see that bits get highlighted. Now, the interesting thing and the important thing to understand is that once the data from google.com is on our browser, that data is outside the control of the google.com server. For example, in this case, this HTML element represents the logo. I can edit this HTML and remove the logo. In fact, I can go a step further and insert a new HTML element. And you can see that this HTML element has now gotten inserted onto the web page. Of course, this is a change that I've made temporarily onto my own. And if I go back to google.com, you'll notice that google.com serves a fresh page. Let's take a look at what kind of requests and responses happen when we make a request to google.com. I refresh my page, and now you'll notice that a lot of requests have been made. In fact, a total of 16 requests have been made and 61 kilobytes of data have been transferred from google.com to my browser. And the total load time is about 424 milliseconds. If you look at the various types of data that the google.com server has responded with, let's look at the type column. And you can see that it has responded with many kinds of data. There are PNG images, for example, the Google logo. Click on this image and you can see the preview. So that is in fact the image. In fact, I can take this image and open it up in a different tab. And so I can get just the Google image that is being used on this web page. During our small experiments, when we right-clicked on the web page on Chrome and clicked on Inspect, the window that opened up is called Chrome Dev Tools. This is a very powerful analysis and debugging tool, and you should definitely read more about it and use it as you surf the web. Just to quickly summarize, in this session, we took a high-level look at what it would take for us to build a web app. We looked at domains, we looked at hosting, we looked at what it would take to build a web server, and what deployment also means.